This is unit 6.10, so 6.10 review. These are going to be problems number 4, 6, 8, and 10. So number 4 I already have written out here with the answers. All right, you're calculating the area using the 24 rectangles. So you have to do the sum of the sequence of your equation multiplied by the width. So this width, 13 over 20, 120, some of you might be wondering where I got that from. The width comes from taking the upper bound, subtracting the lower bound, so 3.1 minus the 0.5 gives you 2.6. Divide that by 24. All right, so what I did is, I don't like having a decimal in my fraction, so instead of leaving it as 2.6 over 24, I used my calculator, I converted it into another fraction, and that's the 13 over 120. So that's what I will use. So that's the equation times by the width, comma the x, comma the start value here, and then the end minus the width, comma the width. Plug it in, you get 8.272. Do the same thing with the right side, but this time it's 13 over 120, comma x, comma the start, the 0.5, plus the width, 13 over 120, comma the end, comma 13 over 120 again. That's your width. That gives you 8.725. Take the average of those two and you get 8.499. All right, so what we're going to look at next here is number 6 through 10, so 6, 8, and 10. So when you're doing these, you're really just going to be taking the integral. So I'm going to set up here for number 6 and number 8, and then we'll slide down and do number 10. So number 6 here, what I notice is the first thing I have is a fraction. I want to change that fraction, so I'm going to make this to be the integral of 1/4. The 4 stays on the bottom. That's a common mistake. The x is what goes to the top. We're integrating there really with that x. X that goes to the top is the x to the negative 3. And this is minus 3, and then x to the 2/5. You rewrite that radical. Remember, this whole thing is in parentheses. You have your dx there. Remember that dx is like your permission slip to integrate with respect to x. And now you actually go through and integrate. So you add 1, you get the x to the negative 2. Divide by that, so you have negative 1/8. Over here, you're going to add 1, so you get x to the 7/5. And then you divide by the 7/5, which means you flip and multiply. So when you do so, that becomes a negative 15 over 7. Don't forget about the plus c. And that's your answer there. Number 8, very similar. You have tangent and you have secant squared. Typically, when you have two trig functions, you need to replace one of them as u. That's exactly what we're going to do right here. We're going to make the u equal to my secant of x. I'm sorry, that's incorrect. We're going to make my u equal to the tangent of x. So this is a little bit different. All right, you notice most of the time you're going to make it whichever has the higher exponent. That's typically what you're going to use as your u. But if you did that here, you took the derivative of secant, you're going to end up with secant tangent, and it's not going to cancel out. So that just doesn't work. So instead of showing that, I'm going to jump to the correct way of doing this, which is to make your u equal to the tangent of x. So again, u is equal to tangent of x here. Du is equal to derivative tangent is going to be secant squared. And that's why this method works out better. Because the derivative of tangent is that secant squared, so it's going to end up canceling out. So when I rewrite it over here, I have the integral of my u, and then secant squared of x du all over secant squared of x. So you can see it's pretty neat and clean once you figure out that the u should be the tangent, but hey, the secant squares here cancel each other out. So all I really have is the integral of u du. So when you integrate that, that's going to become 1/2 u squared plus c, and then you replace your u, and this becomes 1/2 tangent squared plus your c. So again, for those people who start out with secant as your u, I totally understand that. So if you did that as secant, again, just reflecting back, if you do u is equal to secant, you take your derivative, you're going to end up with secant tangent. The tangent will cancel out, but you're left with secant, so you're stuck. So remember what I've always said, whenever you are doing this, if something doesn't cancel out, remember all those x's need to cancel out. If it doesn't cancel out, one of two things happen. Either you chose the wrong u, which is what's happening in this case, or you took the derivative wrong. Okay, you just have to make sure you're careful. All right, moving on to number 10 here, we have the integral of x plus 2 times by the x squared plus 4x plus 7, all to the negative 1/2. 1/2 because it's under the radical, negative because it was on the bottom, bring it up to the top. That's our dx. We're going to find out our u here is going to be the x squared, excuse me, plus 4x plus 7. du is going to equal to 2x plus 4. times by our dx. Okay, so when I replace this now, this is going to be du over, I'm actually going to factor out a 2 here. Just looking ahead, I need an x plus 2. So this is 2 times x plus 2 over here is equal to that dx. So now when I replace it, it's really simple to see that, hey, that x plus 2 that I need to get rid of is going to cancel out. So this is u to the negative 1/2 du over the 2 times by that x plus 2. Remember, you need that x plus 2 to cancel out. We have now du, which is permission to integrate with respect to u, not with that x. Those x's need to go away. So I have the integral now of 1/2 u to the negative 1/2 du. Add 1 to the negative 1/2, you get 1/2, divide, the 1/2 goes away. So this is just going to be u to the 1/2 plus c. Take your u, which is the x squared plus 4x plus 7, plug it back in,